everyone, I am Deepika and today I will be teaching you hybridization. I will be covering two topics today. Firstly, what is hybridization, and second, how to find out the hybridization in a molecule. Okay, so before starting with what is hybridization, we should know what is the need of hybridization. So a long time ago, scientists were trying to find out the structure of methane molecule. Okay, so this is how they proceeded. They knew the electronic configuration of carbon is 2,4, or we can write it as 1s2, 2s2, 2p3, 2p2. Now, this is the ground state electronic configuration of carbon. But here, the carbon has only 2 unpaired electrons. We know for a bond formation, we need an unpaired electron. There are 4 hydrogen, and so we need 4 unpaired electrons. So from 1 electron from the s orbital excites to the p orbital to give us this excited state electronic configuration, which is 1s1, 3p3. Here each hydrogen can overlap with 1 orbital to give us methane. This is very clear. Okay, so from this structure, scientists assumed, they assumed that since 1 hydrogen will be interacting with S and 3 hydrogen will be interacting with P, and S and P have different energy and different structure, so there should be 2 types of bond length in methane. One should be shorter than the other 3. This is all they assumed, okay, theoretically. Then when experiments were performed, they found out that all the bond length of methane are equal and the bond angle of methane is 109 degree. So to explain this, the concept of hybridization was introduced. This concept was introduced by Sir Pauling. Okay, so let us understand what is hybridization now. Hybridization is the intermixing of atomic orbitals of different energy, resulting in the formation of new orbitals with same energy and shape. You can correlate this concept with this explanation. We intermixed 2 atomic orbitals which were having different energy and shape, resulting in the formation of hybrid orbitals, that is sp3 hybrid, 1s and 3p hybrid orbitals. All of them are having same energy and same shape. From this, we can explain the experimental founding. That is why all the hydrogens attached in methane have same bond length, and this is the bond angle. So this is how hybridization explained the structure of methane. Okay, so let's now move on to the second part, which is how to calculate hybridization in a molecule. This is a very simple formula. Okay, H equals to V plus M minus C plus A by 2. Repeat it after me. H equals to V plus M minus C plus A by 2. Here, V is number of valence electrons, M is number of monovalent atom. Monovalent meaning only one valency. That is, valency is 1, which is hydrogen, and fluorine, chlorine, bromine, iodine. That is halogen and hydrogen. Okay, C is charge and cation, and A is charge and anion. Now I'll be explaining you this formula with the help of some examples. Okay, so first example, let us take methane. Okay, for methane, if we calculate H, one more thing, you need to remember this table. If H comes out to be 2, then it is sp hybrid. If it is 3, it is sp2 hybrid, 4 sp3 hybrid, and so on. Okay, so in methane, the central atom is carbon. Okay, so H will be, number of valence electron is 4, and number of monovalent atom, that is hydrogen. There are 4 hydrogens, so 4 plus 4 by 2, which will give you 4. 4 means sp3 hybridization. Yes. Let's take second example. The second example is HCF4. Okay, here you know the central atom will be Hc, that is xenon. This is noble gas, So the number of valence electron in noble gas is 8. 8 valence electron. V plus M will be monovalent atom. There are 4 monovalent atoms. 8 plus 4 by 2, which will be 6. 6 means sp3. So the third example is TeCl6 2 minus. Here we know the central atom is tellurium. Tellurium is from oxygen family. So the number of valence electrons will be 6. Plus chlorine is halogen. So number of monovalent atom will be 6. And there is 2 negative charge. We know the charge in anion should be added in. So we'll add plus 2. Giving it 6 plus 6 plus 2 by 2. 7. Okay, 7 means sp3d 3 hybridization. I guess it was very clear till now. But now imagine what if you are giving a competitive exam and you have time constraint. What are you going to do then? So for that I'll give you a trick. You need to remember this simple formula, which is you have to calculate steric number with lone pair and sigma bond. What you need to remember is lone pair should not be in conjugation. That means if there is a lone pair like this, which is in conjugation with double bond, you will not count this lone pair. The lone pair that you are counting should not be in conjugation, and the sigma bond can be either covalent or coordinate. Okay, simple. Now I'll give you some examples of the same. First example I am giving ClF3. Here the central atom is Cl. Okay. So draw the central atom. Write it Cl. Now chlorine has how many valency? How many valence electron? 7. So draw 7 dots around chlorine. 3 fluorines are attached. So attach 3 fluorine with the electrons. Okay. 2 lone pairs are left. Now steric number here will be 1, 2, 3. 3 sigma bonds plus 1, 2. 2 lone pair. That means 5. 5 steric number means sp3 dehybridization. Simple. Second example is XeOF2. Here Xe is the central atom and it is a noble gas. So 8 valence electrons. Oxygen will form a double bond. 2 fluorines. Draw 2 fluorines around it. Now only 2 lone pairs are left. What will be the steric number? 1, 2, 3. 3 sigma bond plus 2 lone pairs, which will give 5. That means sp3d hybridization. I hope it was all clear. So I'll wrap it up again. And what we learned today was, firstly, hybridization is intermixing of atomic orbitals with different energy, leading to formation of new orbital which have new orbitals which are hybrid orbitals, and they have same energy and shape. Okay. Second thing we learned was this formula, that is H equals to V plus M minus C plus A by 2. Okay. And third was this trick which you can use in exams like JEE and NEET. I hope all of this was clear to you. Thank you.